Good evening, students. So today we will be discussing solution chapters. Okay. So firstly, I'll give you a brief idea about what is solutions. Okay, what all we are going to cover in solutions. So what are solutions? Yes. So solutions, they are homogeneous mixtures. Okay. So what do you mean by homogeneous mixture? Homogeneous mixture means when you add two or more components. Okay. So they will be uniformly distributed. So there won't be any phase between them. There will be no any phase. Okay. So it will be uniformly distributed. So it is called as homogeneous mixture. For example, salt solution. Okay, so if you add salt in water, so it becomes what? It becomes a salt solution. So it is a example for a homogeneous mixture. Okay, so there won't be any separation. So the sugar get dissolves completely in the water, or for example, salt solution. Okay, salt solution also same. Salt solution also, the salt gets easily dissolved with water. So there won't be any this. Okay, uniformly it will be distributed. So the solutions, they are called as homogeneous mixtures of two or more components. So when you mix two or more components, then they are called as solutions. So generally, whenever you are considering the solutions, there are two components which are present. The one component which is present in a larger quantity, it is called as solvent, and the component which is present in the lesser quantity is called as what? It is called as so it is called as solute. Okay, so we have discussed what is solutions. So solutions are homogeneous mixtures which are made up of two or more components. Okay, so for example, as I discussed about salt solution, now you are taking salt in very small quantity, or it is in a lesser quantity. So when you are taking salt in very less amount, then it is said what? It is called as solute. So whenever the component is present in very lesser quantity, then it is called as solute. And the component which is present in large quantity, for example, when you're adding the salt in water, so water is what? Water is your solvent. So water is acting as your solvent. So water is said to be what? It is called as solvent. So here, so what are the terms? Solutions. So solutions are homogeneous mixtures of two or more components. So the component which is present in lesser quantity is called as solute, and the component which is present in more quantity is called as solvent. Okay, so these are the terms which we are going to use in solution chapter. So depending upon this, so the solutions, they are based upon the physical state of the physical state presence of solute and solvent. They are classified as gaseous solutions, liquid solutions, and solid solutions. So in this chapter, we'll be studying about liquid solutions. So we'll go directly from the theoretic point of view for the strength of solutions. Okay. Now, what do you mean by strength of solutions? Strength meaning you're determining its concentration. Okay, you're determining the concentration of the solution. So whenever you are expressing the strength, or it is called as concentration of solution. So what do you mean by this concentration or strength of the solution? So concentration of the solution is the amount of solute which is present in the given quantity of solution. So the amount of solute which get dissolved, okay, the amount of solute which get dissolved per unit solution or solvent is called as the strength of solution, or it is called as concentration of solution. So these concentration of solutions can be expressed with different methods, or it can be expressed into different formulas. Okay, so what is strength? So the amount of solute. So we have discussed earlier now what is solute, what is solution, what is solvent. Okay, so the amount of solute which is dissolved in the solution or solvent, it tells you or it gives you the exact concentration or strength of the solution. So this concentration or strength of the solution are expressed in various different methods. Okay, the first is mass percentage. Mass percentage, it is expressed as, so mass percentage, it is expressed as W by W. Okay, so mass percentage, it is expressed as W by W. So mass percentage meaning what? So it is, the formula is mass of the solute by the total mass of the solution into 100. Why you are taking into 100? Because it is percentage. You know, whenever you are taking percentage, you have to multiply it by 100. So what is the definition for mass percentage? So it is the mass of the component which is per 100 grams of the solution. So the mass of the component present in per 100 gram of the solution is called as mass percentage. So how it is expressed? It is expressed as mass of the solute by total mass of the solution into 100. For example, okay, if there is 10%, if it is given, okay, if there is a sentence, if anyone's tell you 10% glucose solution by mass, okay, 10% glucose solution by mass. What does this means? This means that there are 10 grams of glucose. You're going to dissolve 10 grams of glucose in it. You are going to dissolve of 10 grams of glucose is dissolved in 90 grams of water. Okay, 90 grams of water, resulting in what? Resulting totally, it will be what? It will be resulting in 100 grams of solution. Understood? So 10% glucose solution means 10% means what? Out of 100, 10 grams will be your glucose, and the remaining 90% will be your water, 90 grams. So 10% glucose solution means 10 grams of glucose, okay, dissolved in 90 grams of water. So the total solution resulted will be 100 grams. Okay, so that into 100. So this is your mass percentage. So this is the way you're going to express the mass percentage. So what is mass percentage? Mass of the solute divided by the total mass of the solution into 100. So this is the first way or first method for expressing your concentration of solution. Okay, so this is clear. I hope this is clear. So we'll go with the second method. So the second method is mass. Okay, so here, so what is mass percentage? It is the mass of the component per 100 grams of the solution. Per 100 gram means what? Out of 100 grams. So I had taken an example here, right? What was the example? So 10% glucose solution by mass means what? 10 grams of glucose is dissolved in 100, in out of 100. If you subtract 10, so it will be what? It will be 90. So 10 grams of glucose is dissolved in 90 grams of water. So total solution resulted will be 100 grams of solution. So mass will be always expressed in terms of W. Okay, W by W. So the mass is taken in W. So you can see here the water also is taken in 100 grams, and your solute also is taken in grams. Okay, so this is mass percentage. Mass percentage is always expressed in grams. So mass percentage, both your solute and solution, totally it will give you in grams. Okay, so this is your mass percentage. So next we'll go with the mass by volume percentage. What do you mean by mass by volume percentage now? Now you can see here mass by volume percentage. Mass, we have seen earlier, it is expressed in grams. Okay, that is expressed in terms of W, and volume will be expressed in terms of V. So this is W by V. Okay, this is W by V. So that is mass will be calculated in grams and volume will be expressed in ml. So you know this. So what is the formula for mass by volume percentage? Okay, so it is the mass of the solute dissolved in 100 ml of the solution. So here what you're going to do, you're going to dissolve 100, that is your mass of the solute is dissolved in 100 grams of the solution. Okay, so this will result into your mass by volume percentage. So your mass of the solute is taken in what? It is taken in grams divided by the total volume of solution in ml. Why? Because you express it in terms of volume. It is mass by volume. So you have to into 100. Why you're doing into 100? Because this is percentage. Okay. For example, so I'll give you a example here. For example, 10% of NaCl solution. 10% of NaCl solution means what? 10 grams. Okay. 10 grams of NaCl dissolved in 100 ml of solution. 100 ml of solution. So this will give you what? This will give you 10% of NaCl solution because you're expressing mass by volume. So whenever mass by volume is there, so the mass will be in terms of grams and your volume will be in terms of ml. So 10 grams of NaCl, okay, 10 grams of NaCl is dissolved in 100 ml of solution. So this is our mass by volume percentage. Okay. Then next is volume percentage. Volume percentage is expressed as V by V. It is expressed by V by V. So what is the formula or what is the first we'll see the definition. So it is the volume of the component per 100 parts by volume of the solution. So what is the definition? It is the volume of the component per 100 parts by the volume of the solution. So what is the formula to calculate volume percentage? So here both the volume of the solute and the total volume of the solution both will be in ml. Okay, both will be in ml. Now, so the formula is volume of the solute divided by the total volume of the solution into 100 because you're taking the percentage. So it will be in 100. So both here it will be in ml. So this will be in ml. So for example, okay, for example, 10% of ethanol, 10% of ethanol by volume. So if they gave a statement 10% of ethanol by volume means what? 10 ml of ethanol, 10 ml of ethanol is dissolved in water. Okay, it is dissolved in water so that the volume of the solution is 100 ml. So totally it will become 100 ml. So you have to dissolve 10 ml of ethanol is dissolved in water so that the total volume of the solution should be 100 ml. Okay. So this is volume percentage. So volume percentage is expressed in mLs. So 10% of ethanol by volume means your 10 ml of ethanol is dissolved in water so that the total volume of the solution is 100 ml. Okay, so this is volume percentage. So next is parts per million, that is ppm. Okay, so this is very important, parts per million. So parts per million, it is expressed as what? ppm. So what do you mean by parts per million? So this is, it is a number of parts of components per million. Per million means 10 raised to 6. Per million means 10 raised to 6 of the solution. So you're going to take the number of, that is the number of parts of the components per million. Okay, per million parts of the solution. So that is, the formula is number of parts of solute or the component upon total number of parts of all the components of the solution. Okay, so this is the parts per million that you have to multiply it by 10 raised to 6. 10 raised to 6 because it is per million. You're going to take per million. Okay, so here this parts per million can be expressed as mass to mass by taking m by m. You can take by volume, that is V by V, and mass to volume. So parts per million, it can be expressed in various entities. Okay. Now this ppm, where this ppm is used or parts per million is used, so whenever the concentration of the solution, okay, it is used to express the concentration of the solution when your solute is present in very minute quantity. You know now what is solute. So whenever the solute or the component which is present in lesser quantity is called as solute. Now if the solute is in very less quantity, okay, first of all it is present in less quantity. In that again, if it is present in very minute quantity, then then ppm is used to find out the concentration. That time you are going to use what? You are going to use parts per million, that is ppm. So for example, concentration of pollutants in air. Okay, in air there will be different pollutants are there. Okay, so in air or in water, so to calculate the percentage or concentration of the pollutants in water or air, then we express it in terms of ppm. Okay. So we express it in terms of ppm. Why? Because in the air as well as water, there are different pollutants which are present, which are in very minute quantity. So it is said to be what? It is said to be, we use the ppm. Okay, in that case. So ppm, it is expressed in microgram per ml. Okay, this is expressed in terms of microgram per ml. Microgram per ml. Okay. So this is microgram per ml. So this is about parts per million. So next we'll go for next is mole fraction. Very important, mole fraction. Okay. So mole fraction. So mole fraction is what? Mole fraction. It is defined as the ratio of the number of moles of one component to the ratio to the total number of moles of all the component present in the solution. So you can see here. So it is a ratio of one component to the total number of components which is present in the solution. Okay, so if you are finding the component, if there are component A and B, so how do you find the mole fraction? You have to find the component of A divided by the total components present in the solution. If you want to find the mole fraction for B, take the mole fraction of B divided by the total mole fraction of A plus B. Okay, so these are the mole fractions. So it is defined as the ratio of number of moles of one component to the total number of moles of all the component present in the solution. Okay, now mole fraction, you can see these are the formula to calculate the mole fraction. One more thing, the sum of all the mole fraction. Okay, so these are mole fractions. So sum of all the mole fraction is equal to 1. So the sum of all the mole fraction is equal to 1. So this is very important. So mole fraction is also very important concept. Then, so the next is molarity. Okay, what do you mean by molarity? So it is defined as the number of moles of solute which is present in 1 liter of solution, or it is now that is the number of moles of solute dissolved in 1 liter of solution. So the volume of solution is taken in liters. Okay, it is taken in what? It is taken in liters. Okay, so the volume of solution is taken in liters. So the unit is mole per liter. So this is molarity, very important, molarity. Next is molality. So this is expressed as capital M. This is expressed as small m. Then what is molality? Molality is number of moles of solute dissolved in 1 kg of solvent. Okay, so here the solution taken is in liters. This is the mass of the solvent in kg. It is in terms of kg. You express it in terms of kg. So here, what will be the unit? Mole per kg. So it is defined as the number of moles of solute per kilogram of the solvent. So molality is expressed in terms of kilogram. Okay. So this is example of molality. For example, if I tell you 1 mole per kilogram solution of KCl. Okay, means what? means 1 mole of KCl. Okay, 1 mole of KCl is dissolved in 1 kg of water. Okay, so this is the example. So if 1 mole per kg of solution of KCl means what? 1 mole of KCl is dissolved in 1 kg of water. So 1 mole of KCl means 1 mole of KCl is equal to 74.5 grams. Okay, so this is the 1 mole. So this much grams of KCl, if you dissolve in 1 kg of water, then it is said to be 1 mole per kg solution of KCl. Okay, so this is the terms. Okay, so these are the ways you are going to express your solutions. Next is normality. So number of gram equivalent of solute divided by the volume of solution in liters. So this is expressed in terms of N. Okay. So, so your normality, you are going to calculate the gram equivalent weight, okay, of the solute by the volume of solution in. Okay. So next we'll start with the questions. So the first question is, so if 2 grams of NaOH is present in 200 ml of its solution, its molarity will be, okay, so its molarity will be. So the options, there are 4 options. So we will solve this. So just now we have seen what is molarity, right? So what is molarity? Molarity is, what is molarity? Molarity is number of moles of solute divided by number of moles of solute divided by the volume of solution in liters, right? So yes, you have to solve this. How will you solve this? What is given? The mass is given. So given mass of the solute is given, that is 2 grams. What is given? Volume of solution is given. So volume is given, but it is given in ml. What you have to find? We have to find the molarity. Yes. So molarity, what is molarity? Molarity is, we have to find out. Now first we'll express this ml. Okay. Now volume is given as 200 ml. Volume is 200 ml. Okay, so this we have to convert it into liters, right? We have to convert it into liters. So what you have to do? 200 divided by 1000. Okay, 200 divided by 1000. So 2 ones are, 2 fives are. So this comes to 1.5 liters. Okay. So it comes to 1/5 liter. Then, so this is volume which we are getting. Next is we are going to find the number of moles of solute. So next step is what? Number of moles of solute. How to find the number of moles of the solute? By using the formula given mass upon molecular weight or molecular mass. Okay. Now what is the given mass? Given mass of solute is 2 grams. Okay. Then what is the molecular mass of NaOH? Okay, what is the it is 40. Okay, how? Sodium is 23, oxygen is 16, and hydrogen is 1. So it comes to be 14. So this is the molecular mass of NaOH. So it comes to what? It comes to 40. So this, okay, I'll keep it as it is, 2/40. So okay. So next step is what? So we got the volume, we got the number of moles. Next step is we have to calculate the molarity. So molarity, what is the number of moles of solute? Number of moles of solute is 2/40. Okay, so 2/40 divided by, what is the volume of solution in liters? It is 1/5. Okay, so this 2/40. Now this will go to numerator. So this will be 5. So 5 ones are 5 eights are 40, 2 ones are 2, 4s are 8. So 1/4 is nothing but what? It will come to 0.25. So answer A. So most of you, what you have answered, let me see. Yes, so many of you have answered it A. Yes, some have answered it B, but yes, most of you have answered it as A. So A is the correct answer. Right. Okay. So A is the correct answer. Okay, so this was the way of solving this molarity formula. Okay, so by using the molarity formula, so whenever ml is given, you have to convert it into liters. Okay, so you have to convert it into liters. How you will convert it into liters? By multiplying it with by dividing it with 1000. Okay, so this is the way. So number of moles of the solute, it can be calculated by given mass upon the molecular mass. Okay, so this is the way you're going to calculate the molarity. Okay, so we'll go for the next question. The atmospheric pollution is generally measured in the units of. Okay, so the atmospheric pollution is generally measured in the units of A, mass percentage, B, volume percentage, D, volume fraction, C, volume, D, ppm. Yes. Yes, so just now when I was telling the synopsis, okay, we have just discussed it. It is what? It will be D. Why it is D? What is the reason why it is D? Because, why it is D? Because since the amount of pollutant which is present in the atmosphere is very small, okay, so the atmospheric pollution is measured in ppm. So it is measured how? It is measured in terms of ppm. Yes. So most of you have answered it as D, and D is the right answer. Good. Okay. So ppm. So atmospheric, just as we have discussed. Okay. So as we have discussed, so the atmospheric pollutants which are present, that is the amount of pollutant which is present in the atmosphere, are in very small quantity or in very small minute amount. So the pollution is always measured in terms of ppm. Okay, so this is the correct answer. So D is the correct answer. So we'll go for the next one. A 5% solution of cane sugar, okay, the molecular weight is given as 342, is isotonic with a 1% solution of substance A. The molecular weight of X is, okay, so this is our question. Now, as we have expressed, okay, we have seen, so just now we have seen how to write such this, okay, 5%. So there are two solutions. So first we'll discuss what all is given. So there are two solutions. One solution is of unknown concentration, another solution is of known concentration. Okay, so one solution concentration is 5%, that is cane solution. Another solution, we don't know which is the solution given. Okay, in that the concentration of one cane sugar is 5%, and that of other solution which is unknown, it is 1%. Molecular weight is given of cane sugar. We don't know the molecular weight of the unknown solution. So from this we are going to find out. So we are going to use the formula, okay, and we have to find out the molecular weight of X. Now here they say that both the solutions are isotonic with each other. What do you mean by isotonic? What do you mean by isotonic? Yes, what do you mean by isotonic? Isotonic means they are having same, that is same osmotic pressure. Yes, so they both the solutions are having same osmotic pressure. So when you say that both the solutions are having same osmotic pressure, then it is said to be isotonic. Okay, now now here 5% 5% solution of cane sugar means what? 5 grams of 5 grams of cane sugar in 100 ml of solution. Okay, 100 ml of solution. Now 1% means what? 1% means 1 gram of substance in 100 ml of solution. Okay, so these are the, so we know now what is 5%, what is 1%. So now we'll take two solutions. Understood? This is understood. I'll clear it. Okay, I'll just clear this. I'll write here now. So how it will be? So I'll take substance 1, substance 2. So which is a substance 1? We know that is, it is a cane sugar. This is a unknown. This is unknown. Okay. Now, what is W1? Weight is, it is 5 grams. Okay, it is 5 grams. What is this W2? We'll take it as W2. This will be 1 gram. What is mass M1? It is 342 gram per mole. Okay. And this M2 we don't know. So keep it as question mark. Okay. Then here volume is given is, it is in 100 ml. Okay. Then this V2 is given as 100 ml. Now isotonic. What we have viewed the word isotonic. Isotonic meaning both the concentration, osmotic pressure is same. That means pi 1 is equals to pi 2. What is pi 1? Pi is nothing but osmotic pressure. It is expressed as CRT. Okay. So this is, so the osmotic pressure for both the solutions are same, but the concentrations are different. So we'll take concentration C1 equals to, this will be C2RT. So here both gas constant and temperature are constant. So this and this will get cancelled. This and this will can cancel. So it will be C1 equals to C2. Okay, now how to express concentration? So concentration, I'll just write it here. Okay, so concentration, how to write concentration? Concentration of the solution is nothing but number of moles of solute, number of moles of solute divided by volume of solution. Okay, divided by volume of solution. Now what is, so this is what it is, W1 by M1 into 1000 by V1. Okay, is equals to W2 by M2 into 1000 by V2. So this is the formula. Okay, so that is weight, given weight upon the molecular weight into V1, because V1 is given in ml, so you have to multiply it by 1000. You have to divide it by 1000. Again here for another, that is another unknown solution substance, you are taking W2 upon M2 into 1000 by V2. Now what is W1? These are our entities. So just add what all is given. So W1 is what? W1 is 5. What is M1? M1 is 342 into 1000. Okay. Then V1 is 100 is equals to, what is W2 is 1. M2 is, we don't know M2. So write it as M2 into 1000 and V2 is 100. So this 100 get cancelled, 1000 and 1000 get cancels. Okay. So it will be 5 by 342. Okay. Is equals to 1 by M2. So if you take M2 here, so this will become what? This will become, so you have to just see, it will become 342 by 5. Okay, 342 by 5. Just see what it will come. It will come to 68.4 gram per mole. Okay, so this is the molecular weight. So our answer resembles to option C. Okay, so option C is the right answer. Yes. Understood? Yes, understood. So most of you have answered it as C. Yes, C is the right answer. Okay, so C is the correct answer. So this is the way you're going to solve the problem. Understood? This question is clear. Yes. Shall we move for the next one? Okay, so we'll go for the next question. Okay, so this is the next question is, so 234.2 grams of sugar syrup, it contains 34.2 grams of sugar. So what is the molar concentration of the solution? Molar concentration means you are going to do the molality. So here what you are going to do, it is a molality. Okay, molality problem. So this is a molality problem. So here what you have to find, so they have given the sugar syrup. So it is sugar syrup is completely the solution. Solute weight of the solute is what? Sugar. Okay, that is 34.2. So we want to find out the weight of the solvent. Molar concentration means what? Weight of the solvent in kg. Right. So weight of which is our solvent? Sugar syrup means how do you prepare sugar syrup? You are dissolving your sugar in water. So weight of water in sugar syrup. Okay, weight of the water in sugar syrup is what? It will be 234.2 minus 34.2. So this will give you what? This will give you what? 200 grams. Okay, so this is our weight of the water. So this is weight of the water. So you know that in molar concentration or in molality, your weight of the solvent will be in kg. So this is what? This is expressed in terms of kg. Okay. Now next step is what? What is given here? See, sugar syrup we have seen previously. What is the molecular weight? Molecular weight of cane sugar was 342. So here you can just write molecular weight is given. Okay, it will be given. Molecular weight of cane sugar is 342 gram per mole. Okay, so it will be, so molecular weight of sugar is 342 gram per mole. Okay, this is given. This will be given in the question. Next is what? Molality. Now molality, how do you calculate molality? Molality is number of moles of solute, by mass of the solvent, in kg. So this is the formula. So now you're going to write the, you have to substitute. So number of moles of solute is what? Number of moles of solute is given mass upon this, right? So how do you calculate given mass? Number of moles will be calculated as, just here, number of moles given mass upon molecular mass. Okay, so this is to calculate the number of mass, that is number of moles is given mass upon molecular weight. Now what is number of moles of solute? How do you calculate? Given mass is what? Given mass is 34.2. okay, what is molecular mass? Molecular mass is 342 into what is mass of the solvent? Mass of the solvent is 200. Okay, or see here how it will be. You have to 200. Okay, mass of the solvent is 200. It is in grams, so you have to divide it by 1000. Okay, divided by 1000. So this only you have to rearrange and write it as 32.342 into 1000 by 200. So see what you'll get. Just see what you'll get the answer. Yes. Yes, right. So B is the answer. Yes, B is the answer. So you will get 0.1. Okay, 0.1 into 5. So 0.1 into 1s are 2 5s are, right? So 0.1 into 5, that comes to 0.5. So our answer resembles to B. Option number B. Okay, so B is our answer. So this is our right answer. So we'll check. Yes, most of you have answered it as B. So B is the right answer. Yes. So I hope everyone has understood. So we have solved question on molarity. Okay. Then molality also we have solved. Then mole fraction we have solved. Right. So this is the way. So here, so one more time, I'll just repeat it. So this is a molality, because what is molar concentration of the solution is asked. So this is molality problem. Okay. So how do you, so what is given here? So here 34.2 grams is nothing but your solute. Okay. So weight of the solute. So molality means you have to find the weight of the solvent in kg. So what you, the total volume is given, that is 234.2 grams. So you have to subtract the solute. So weight of the water you will get. So weight of the water in sugar syrup will be 234.2 grams minus 34.2 grams, right? So that you will get the weight of the water. So from this you get your mass of the solvent in kg. So kg means you have to divide this by 1000. Okay, so that you are going to do here. Next is what? Molecular weight of the sugar. So in the last problem we have seen the molecular weight of the sugar is given as 342. So here also in this problem they were not given, but it is given as 342 gram per mole. So molecular weight of the sugar is 342 gram per mole. How to calculate the number of moles of solute? So here remember this number of moles of solute is calculated as given mass upon molecular mass. Given mass we know it is 34.2 divided by the molecular mass is 342, right? So now we'll just write it here. So 34.2 divided by 342. What is mass of the solvent? It is 200 grams. So you have to divide it by 1000. So just rearranging it, you will get this. You get here, so this 34.2 divided by 342, it comes to 0.1. And after solving this, you get it 5. So 0.1 into 5 is 0.5. Okay, so like this, you will get the answer. So our answer is B. Yes, so most of you have answered it right. Okay, so we'll go for the next question. So 25 ml of solution of barium hydroxide on titration with a 0.1 molar solution of hydrochloric acid gave a titer value of 35 ml. The molarity of barium hydroxide solution is. Okay, so this is our question. So what is our question? So there are two solutions. So which are the two solutions? One is a base, that is barium hydroxide. So barium hydroxide. So what is happening? Barium hydroxide, it has been titrated. Okay, so you have done titration. So in titration, two solutions will be there. So two solutions. One solution will be of unknown concentration. Another solution will be of known concentration. Okay. So here also it is same. So one solution's concentration and volume is given. Another solution volume is given. So you have to find the concentration of the unknown solution. So the two solutions are barium hydroxide and HCl. So plus 2 HCl, it will give you what? It will form barium chloride plus 2 H2O. Okay, it will form barium hydroxide plus 2 HCl, giving you barium chloride plus 2 H2O. Now, the basicity and acidicity. So here the acidicity of base is 1 and basicity of acid is 2. Now we are going to use the formula M1V1 equals to M2V2, right? So M1V1, you have to, here you can see there are no psychometric ratios, so you have to consider it is 1. So this is 2, so consider this as 2. Now what is the M1? So this will consider for barium hydroxide. Okay, on the left hand side we'll take barium hydroxide, this will take HCl. Okay, now barium hydroxide, what is the, we have to find the molarity. So 25 ml of solution of barium hydroxide. So the volume is given as 25. Okay, 25 on titer with 0.1 molar solution of hydrochloric acid. So hydrochloric acid, what it is 0.1 into what is, it gave you a titer value of 35. So this comes to be 35 divided by 2. Molarity of barium hydroxide is. So M1 we have to find out. So after solving this, what you will get, just see. So after solving this, the answer, okay, it comes to, yes, M1 equals to 0.07 M. Okay, the answer molarity will be C, option C. So option C, so you have to solve it. So what you do, okay, 0.1 into 35, 3.5. So this comes to be 3.5. Okay, then divided by 2. So this comes to be, so this answer, it comes to 1.75. Now what you have to do, 1.75 divided by 25. So this comes to, so here, so this 1 point, so here again, I am just simplifying for who did not understand. Okay, so 0.25, it comes to 0.07 M. Yes. So yes, most of you have answered it as C. So C is the correct answer. Yes, good. Okay. So we'll go for the next question. Yes, I hope you have understood this. Shall we move to the next question? Yes. Okay. So we'll go with the next question. Okay. So here the next question is 6.022 into 10 raised to 20 molecules of urea is present in 100 ml of its solution. The concentration of the solution is, okay, so we have to find the concentration of the solution. So here, so we are going to use the formula as, so for 1 mole, okay, so 1 mole of urea contains what? Whenever you're considering 1 mole means it contains Avogadro's number. Avogadro's number is what? 6.022 into 10 raised to 23 molecules, right? So this is Avogadro's number. So whenever you are considering the Avogadro's number, it will be that is 1 mole of urea is equals to 6.022 into 10 raised to 23. Now, so the number of moles of urea. So the number of moles of urea in how many? In 6.022 into 10 raised to 20 is how much? So what you have to do? You have to do the cross multiplication. So this comes to be 6.022 into 10 raised to 20 divided by 6.022 into 10 raised to 23. So after solving this, what you will get? You will get it as 0.001 mole. So we are just comparing it as what? 1 mole of urea contains Avogadro's number, so many of molecules. So number of moles of urea present in these many are how many? So what you have to do? You have to just multiply, cross multiply. So you will get the number of moles. Now next step is what? After finding the number of moles, you have to find the concentration of solution. So you know how to find the concentration of solution. Concentration of solution is what? Number of moles of solute, okay, divided by the volume of solution in liters, right? So you know this. Now what is number of moles of solute? Number of moles of solute is 0.001, okay, and divided by volume of solution in liter. It is 100 ml. 100 ml means you have to multiply it by 10 raised to minus 3 or into 1000, okay. So this 10 raised to minus 3 and this also is 10 raised to minus 3, right? So this can be written as 10 raised to minus 3. So this and this get cancelled. So it will be 1 by 100. 1 by 100 is 10 raised to minus 2 m. 10 raised to minus 2 is nothing but 0.01 m. So our option B is the right answer. Okay. So option B is the right answer. So we'll just check. Most of you have answered it as C. C is not the answer. It is 0.01. Okay, 10 raised to minus 2. Just see, in shifting the decimal, you might have done the mistake. So the answer comes to be 0.01 molar. Okay, so these many molecules of urea which is present in 100 ml of solution, the concentration will be how much? It will be 0.01. So we are calculating. So they have asked, so there are 6.022 into 10 raised to 20 molecules of urea are present in 100 ml of solution. So they are telling to find out the concentration of these many solution of urea. So what we are going to do, we want to find out the number of moles. So how do you calculate number of moles? By taking 1 mole of urea. So 1 mole of urea is what? 1 mole of urea means it contains Avogadro number of molecules. So 1 mole of urea contains 6.022 into 10 raised to 23 molecules. Now, number of molecules or number of moles present in these many molecules are how many? So what I did, I just did cross multiplication here. Okay, so I just cross multiplication. So these many contains this much, for this many, it contains how much? Okay, so we have just done the cross multiplication. So after doing cross multiplication, what it comes to be? It comes to be the number of moles. It comes to be 0.01001. So this can be is nothing but 10 raised to minus 3. Okay. Now concentration of solution. We have seen this concentration of solution is calculated as number of moles of solute. Okay, number of moles of solute divided by the volume of solution in liters. Now, number of moles of solute is what we have found out. It is 0.001. You can write it as 10 raised to minus 3. Okay, you can just write it as 10 raised to, don't write both. It is either one. You can write 0.001 or you can write it as 10 raised to 3. So I'll write it as 10 raised to 3. Then volume of solution in liter is 100 divided by 1000. Okay, so this and this get cancels. So 1 by 100. So 1 by 100 is nothing but 10 raised to 2. 10 raised to 2 is 0.01. Simple calculation. Okay, it is a just simple calculation. So this is the way you are going to solve this particular question to find the concentration of solution. So always whenever they have asked how to find the concentration of solution, the formula is number of moles of solute divided by the volume of solution in liters. Okay, so this is the way of solving this particular question. So next question is 5.2 molar, okay, solution of methyl alcohol. So 5.2 molar aqueous solution of methyl alcohol is supplied. What is the mole fraction of methyl alcohol in the solution? So this is our next question. Okay, so here a 5.2 molar aqueous solution is given. So here the number of, so this is a problem of mole fraction. So this is a problem on mole fraction. So mole fraction, you know how to find the mole fraction. So component, so the number of moles of component A upon total number of components of A and B. Of if you want to find the mole fraction for B, then number of components of A, B upon total number of components of A and B. Now this 5.2 molar mixture means what? This is for methyl alcohol. Methyl alcohol aqueous solution means what? Your methyl alcohol is prepared in water. So our component A is water. So we'll find so number of moles of, so number of moles of water. How do you find the number of moles of water? That is N1 is what? Given mass. So it will be 1000. It will be prepared in 1000 ml. Okay. Divided by the given weight is 1000 upon what is the molecular weight? It will be 18. So this comes to be 55.5. So this is the number of moles of water. Next is number of moles of methanol. That is CH3OH equals to N2. So N2, what it is? It is 5.2. So this is our number of moles. So this is given. Okay, then we have found out the aqueous solution also for water. Now we'll find the mole fraction of methane alcohol. So mole fraction is given as what? Psi of methanol CH3OH is what? So psi mole fraction of N2 by N1 plus N2. So what is N2 is 5.2 divided by 55.5 plus 5.2. Just see what you'll get the answer. Yes, the answer comes to be 0.086. Yes, the option is 0.086. Yes, C is the correct answer. Okay, C is the correct answer. So this is the mole fraction. So whenever you're calculating the mole fraction is nothing but number of moles of component A. If you want to find out the mole fraction for A, it is number of moles of component A upon the total number of moles of A and B. If you want to find the mole fraction for B, then it is the number of moles of component B upon total number of components of A and B. So like this, psi, okay, is equals to Na upon Na plus Nb of A if you want to find out. And if you want to find out for B, it will be Nb upon Na plus Nb. Okay, and always remember the mole fractions, sum of all the mole fraction will be equal to 1. Okay, so these are the very important formulas. Okay, so this is the question based on mole fraction. Understood? Yes. Okay, so we'll go for the next question. Okay, so we'll go for the next question. So the molarity of a solution obtained by mixing, okay, a molarity of a solution which is obtained by mixing 750 ml of 0.5 molar solution, okay, solution of HCl with 250 ml of 2 molar solution of HCl will be. So this is a problem wherein you have to find, so there are different concentration of HCl given. So there are two different concentration of HCl. You're going to tell the resultant molarity. So how do you find the resultant molarity? So there are M1 and M2. So you have to tell the M3. So M3V3 is equals to M1V1 plus M2 V2. So how do you calculate? You want to find the molarity of the solution which is obtained by mixing this. So you want to find out M3. So M3 will be M1 V1 plus M2 V2 by V3. Okay. Now we will find out this. So M3 will be equals to. So what is M1? M1 of first solution is 0.5. Okay, 0.5 into what is volume? Volume is 750 plus what is M2 of another solution is 2 molar into, okay, 2 into what is the volume is 250. Okay, then the total volume obtained will be, you know how to find V1 plus V2. V1 plus V2 will give you V3. So V1 plus V2, what is V1? V1 is 750 and V2 is 250. What it will be total? 750 plus 250. So it will be 1000. Okay, it comes to, so here you have to write 750 plus 250. So this is the total, that is B3. Okay, now solve this and see what you'll get the answer. Yes, after solving, what you'll get the option? Yes. Yes, good. So it comes to be 0.875 molar. Okay. So option C. Option C is the right answer. Option C is the right answer. Yes, good. So many of you have answered it right. So C is the right answer. So we'll solve a last problem and then we will stop. Okay. So our next. So here. So when the concentration is expressed as a number of moles of solute per kilograms of the solvent, then it is called as what? Yes. When the concentration is expressed in terms of number of moles of solute per kilograms of the solvent, then it is called as, yes, it is called as molality. Okay, molality. So your option, this is right. So option what? Option B is right. So molality is right. Okay, molality is correct. Why? So whenever you are expressing number of solute, that is number of moles of solute, okay, per kilograms of the solvent, then it is said as molality. And what is molarity? Number of moles of solute dissolved in per liter of solution. Then it is called as molarity. Okay. So molarity, it is dissolved in 1 liter of solution. Normality is what? You are taking the gram equivalent weight, okay, in 1000 ml of solution. So this is also wrong. Mole fraction, you know what is mole fraction? So it is the number of moles of component A upon the total number of moles of A and B. So this is also wrong. So B is the right answer. Okay, I hope you have understood whatever the questions have been discussed today. Okay, so we'll stop the session here. It was nice talking to you all. Okay, we'll meet in the next class. Thank you, dear students.